Something's wrong. So, as scientists, error is how wrong you were, right? Fair is how wrong you were correct. Don't want to say right. So, we're going to start off with, in order to know how wrong I was, I have to know the right answer. The right answer is called the accepted value. We can't call it the right answer because the best we can do is it's the accepted value is based on reliable evidence references. It's the best we can do. Your textbook is one of your reliable references. When you're using the internet, check the site to see if it's reliable. See who wrote it, for what purpose, who they are. Yeah. That's the right answer, and then you're going to have what you get in the lab, and that's called the experimental value. What you get when you measure it. So how would you use those two numbers to figure out how wrong you were, what your error was? Subtract. Experimental value minus accepted value. That's how wrong you were. But notice it doesn't just say the difference, it puts it in an order. Okay? This can be a negative number. How would you get a negative number doing that math? The accepted value is higher than what you got, right? I'm subtracting too big a number. So that means that your answer was too low. Positive would mean that your answer is too high. Now, if you had an answer that was off by 2 grams, did you do a good lab or a bad lab? Was your accuracy good or bad? You're off by 2 grams. Yeah, see, it matters what the correct answer is. Because if you're off by 2 grams out of 4, that's a 50%. You're off by 2 out of 4, you're half off, right? But if you're off 2 grams out of 2 million, you got a little tiny error. So error by itself doesn't tell us very much. We need to compare it to the right value. And that is called percent error. So percent error is the experimental value minus the accepted value divided by that quantity divided by the accepted value times 100%. Hey, look, we got subtraction, division, and multiplication all in the same problem. We might have to do complex sig figs. Okay. This 100% is a definition. That means it's got unlimited sig figs, so it won't affect the sig figs at all. It's exactly 100. It's 100.00000. Okay? So, hey, we can shorten this down a little bit because we have seen experimental value minus accepted value before. Look up 2 lines. This was called error. What's on top is error, right? If you put error over the accepted value, that's your percent error. How wrong you were over the right answer. And the sign's important again. If I get a positive error, that means my subtraction was positive, which means my experimental value was higher than my accepted value, that my experimental value was too high. That's how I'm going to get a positive number. if experimental value is big. And I'll get a negative answer if the experimental value is low. Because I'll subtract a bigger number from a smaller number, get a negative number. So, what if I know I weigh 150 kilograms? Then I weigh myself and the balance says I weigh 165 kilograms. What's the percent error? Well, there's the equation. Percent error equals experimental value. Which one of those is the experimental value? I weigh myself on the balance. That's the experiment, 165 kilograms. Minus the accepted value, 150 kilograms, divided by the accepted value, 150 kilograms, times 100%, equals. Okay. Anybody think about sig figs while you're doing this? Because first I have to subtract, then I have to divide. So I have to follow both rules. So I do that subtraction. 165 kilograms minus 150 kilograms gives me 15 kilograms. Last sig fig in 165 is the 5. Last sig fig in the 150 is the 5. That 0 doesn't count. So I need to round this off to the tens place. That's 20 kilograms. Everybody okay with me so far? So now I have 20 kilograms divided by the 150 kilograms times 100%. So 20 divided by 150 equals times 100. Okay, the 20 has how many sig figs? 1. The 150 has 2, and the 100 has unlimited. It's a definition. So 1, 2, and unlimited, the smallest number is 1. So instead of the 13% of my calculator, I write 10%. Maybe okay with that? So yeah, we put those two pieces together. You guys didn't think about sig figs when you subtracted first. You pushed the buttons in your calculator. And remember, you got to stop and think. When I change from that subtraction problem to that division problem, I need to stop and round. Okay, student measures the mass of a pencil. He finds that it's 25 grams. The actual mass is 22 grams. What is the student's percent error? So it's experimental minus actual over actual times 100%. So the experimental value, when he measured it, he found it was 25 grams minus the actual, which was 22 grams, divided by the actual, which was 22 grams, times 100%. 25 minus 22 is 3 grams. What about sig figs there? That's the right sig figs, because 25 grams minus 22 grams is 3 grams, and they're both at the ones place. Divided by the 22 grams times 100%. 3 divided by 22. Calculator fills up times 100. Calculator fills up with numbers. How many sig figs in my answer? Well, the 3 has 1 sig fig and the 22 has 2, and the 100 has unlimited. So I can only have 1 sig fig, which makes it, again, 10%. When we write down 10%, that means someplace above 0 and less than 20. Right? We're not sure that's really a 1. Make sense? Really complicated? Okay, so these pieces fit together. They're not separate pieces that we do this here and this here and this there. Tomorrow when we get our calculators, we'll deal with scientific notation in your calculator and how that messes up rounding. Okay? And then we'll start on the other half of these pieces, which is the grams, to talk about the metric system. But tonight you're going to do Reading Guide 2.2. That is the second side. You did it out of order. You did 2.3 first, then you did 2. I need you to do 2.2 now. Okay? You okay with that? All right.